Good day everyone, my name is Kyla Rusiana. My topic is all about the reduction to produce sugar alcohol. So, the carbonyl group present a monosaccharide, either an aldose ketose can be reduced to hydroxyl group using hydrogen as the reducing agent for aldose and ketose. The product of the reduction is the corresponding polyhydroxy alcohol, which is sometimes called a sugar alcohol. For example, the reduction of N-glucose gave D-glucitol. Diagram 1. This is what we call reduction of glucose to sorbitol. Top left, this shows the chemical structure of glucose. Notice the carbonyl group or C double bond O at the top. This is the K functional group that gets changed in reduction. Top right, this shows the chemical structure of sorbitol. The carbonyl group C double bond O in the glucose has been converted to a hydroxyl group COH. This is what happens during reduction, adding hydrogen across the C double bond 0 bond. Glucose is a sugar with an aldehyde group or a type of carbonyl. Reduction also involves adding hydrogen to this aldehyde group. This turns the aldehyde into an alcohol, resulting the formation of sorbitol, a sugar alcohol. D-glucitol is also known by the common name D-sorbitol. Hexahydroxy alcohols such as D-sorbitol have properties similar to those of the trihydroxy alcohol glycerol. Section 14.5. These alcohols are used as moisturizing agents in foods and cosmetics because of their affinity for water. D-sorbitol is also used a sweetening agent in chewing gum. Bacteria that cause tooth decay cannot use polyol alcohols food sources, as they can glucose and many other monosaccharides. D-sorbitol accumulation in the eye is a major factor in the formation of cataracts due to diabetes. Glycoside formation. In section 15.11, we learned that hemiacetals can react with alcohols in acid solution to produce acetals because the cyclic forms of monosaccharides are hemiacetals. They react with alcohols to form acetals, as is illustrated here for the reaction of B-D-glucose with methyl alcohol. In diagram 2, we called it hemiacetal formation or implicit in glycoside formation. So, in top, this shows a linear form of glucose or a similar aldose sugar. Notice the aldehyde group CHO at the top. In the middle, this shows the cyclic hemiacetal form of glucose. The aldehyde group has reacted with hydroxyl group O or OH within the same molecule, forming a ring structure. The carbon that was part of the aldehyde group, or now labeled C1, becomes a hemiacetal carbon. In the bottom, this represents the glycoside formation. The hemiacetal OH group on C1 reacts with an alcohol represented as ROH to form an acetal, especially a glycoside. General name for monosaccharide acetals is glycoside. A glycoside is an acetal formed from a cyclic monosaccharide by replacement of the hemiacetal carbon OH group with an OR group. More specifically, a glycoside produced from glucose is called glucoside. That from galactose is called a galactoside, and on. Galactosides, like the hemiacetals from which they are formed, can exist in both A and B forms. Glycosides are named by listening the alkyl or aryl group attached to the oxygen followed by the name of the monosaccharide involved with the suffix independent. Diagram 3. We call this glycoside formation methyl glycoside. Bottom left, this shows the structure of methyl A or alpha D glucose, and bottom right, this shows the structure of methyl beta or BD glucose. Thank you for listening.